What's going on, guys? This is a software ink and I'm Lordman. In this particular video I will show you how can you draw the shear force and bending moment diagram by using Ansys software. So as you know the drill, everything is explicitly given on the problem. So as you see from the problem, material properties, geometrical properties, loading condition, even the finite element model is given to you. So what we have to extract from the solution is just you have to plot the shear force and bending moment diagram by using this software. Now I will show you how can you do this step by step. Keep watching. Once you open the mechanical APDL, which is one part of the Ansys software. So the graphic interface window will be like this. So to start with, you have to set your preference. I'm doing a structural analysis, so you have to select the structural disciplines only. After that, we have on the preprocessor stage, we have to select our element type. So our element type is beam. So beam and 188 is our element type. So it hasn't a real constant. So what we have to do is just select put our material property. So in this particular example, the material property is the modulus of elasticity in this magnitude, and the Poisson ratio is 0.3. Now after selecting our material type, we have to select our section. So in the section command there is a beam. So from beam, let us select a common section. So in this problem, our section is rectangular, so B and H must be given. So our H is 10 centimeter and our height is 10 centimeters. So be careful in Ansys software, there is no unit, so unit homogeneity is very necessary. So if you want to see the cross section, you can see preview. So the cross section is here. So let us by okay. So this beam has a cross section of 10 by 10 centimeters. That means a square cross section. Once we select the cross section, we are on the modeling stage. We have to create nodes. So we have to create nodes in the active coordinate system. So the first node is the origin. The second node will be 12 centimeters from the origin. So the third one will be 24. The fourth one will be 36. And the fifth one will be 41. So I create 5 different nodes. After creating those nodes, I can create now element by using nodes. So elements auto numbered by using nodes. I can create elements. By saying apply, you can create 4 different elements. Once after you create your element, what you have to do is just applying the loading conditions. So as you see from the problem, on the solution stage, you have to define the load. Apply displacement on nodes. So as the first node, there is no any displacement. So let us select all degree of freedom. So this fixed at the left end, and also on nodes at this point there is a vertical support in the y direction, but it is free in the x direction. Now we have to delete this one, the structural displacement on nodes. Let us select this one. So we have to reapply the displacement on node, so at this point in the vertical direction only, yeah, here. And also at node 4 there is also a vertical roller support at node 4. Apply, okay, yeah. So this is fixed at the left end. At node 2 and 4 there is a roller support or a support on the vertical direction only. And after that we have to apply the force. For example, at node 5 there is 2 kilonewton load, vertical load. That means 2 kilonewton means 20,000 newton in the downward direction. And also at node 3 there is also another force. At node 3 the magnitude is 7,000, I mean 7,000. And also there is a pressure on element 1, so we have to put this element, select pressure on line, I mean on beam, pressure on beam. So on the first beam we have to apply the magnitude 7.5 Newton per centimeter square. Yeah, so I apply 3 loads. The first one is pressure, line pressure on the beam 1, and the transversal load at node 3 and at node 5. So after applying all the loads, what we have to do is just solve. We have those 3 loads are on the single load step, so we have to solve as a single load step. Oh, it is good news, the solution is done. So once the solution is done, we can extract any result from the general post-processing stage. But in this particular video, in this particular problem, we want to train how can we plot the shear force and bending moment diagram. So from the general post-processing stage, we have to create element, define element. So we have to add the first one. You have to know the syntax for plotting your shear force and bending moment diagrams. So or you can see the Ansysmechanical APDL help. For this case, let me tell you how can do this. So the first by sequence numbering, the first syntax is 3, apply. The second syntax is 6, apply. Sixteen, apply. So those 4 syntax are enough for plotting a shear force and bending moment diagram. So once after we define the table from the plot result, counter plot line element results. For example, if you want to the shear force and bending moment diagram, you have to select syntax 3 and syntax 16. So if you want to see, you can say okay, so the shear force and bending moment diagram will be like this. The shear force diagram will be like this. So similarly, if you want to see the bending moment diagram, so the bending moment diagram will be like this. Attention here, if you want to know the syntax, more about syntaxes, you have to get in the Ansysmechanical APDL help, so you can get all the syntax used for doing such problems. So as all about today's video. If you want to get more updates, please subscribe my channel and like my video. Thanks for watching. Thanks.